Okay, we retain another integral. This one's from the Vienna integration bee 2024, number 68. We have the integral of x cubed over x to the fourth plus 3x squared plus 2 dx. Okay, this is one I actually did already using partial fractions. In that other video, I did the partial fractions out the long way, and some people mentioned that we could actually do a u substitution and make it a little quicker. And I think this is going to work pretty nice. So the first step is the same. I just want to factor this. So doing that, this is going to factor as x squared plus 2 times x squared plus 1. And then I'll rewrite it, but before I do that, what we want to do is, let's put parentheses around this. So in order to make this work, what I'm going to do is we're going to do a u substitution for x squared. Then take the derivative, du is going to be just 2x dx. So before I substitute, let's rewrite it, but let's create this du. So for x cubed, I can split this up as 1/2 x squared times 2x dx, noticing this part is just x cubed. And for the denominator, we'll write it in this factored form, x squared plus 2 times x squared plus 1. So now we'll go ahead and do the substitution. I'll take this 1/2 out front, put it right there. X squared is just going to be u, and all this part over here is going to be our du. Then our denominator is just going to transform down to u plus 2 times u plus 1. And the nice thing about this is instead of having each term be a quadratic, each term is just first degree. That's going to make the partial fractions a little simpler, I think. So we'll come over here for the partial fractions. And what I'm actually going to do now, we can easily use the cover-up method on this. So we'll break up the denominator as a over u plus 2 plus b over u plus 1. When you split up the partial fractions, you want the numerator to be 1 degree less than the denominator. So when you just do it like this and you have quadratics, then you have to have 4 terms instead of 2. You'd have like ax plus b, bx plus c. It just makes it a little more messy and slow. So doing it this way, we'll use the cover-up method. And what we want to do first is, what do we need to plug into u plus 2 to make it 0? Well, if you plug in minus 2 there, then this is 0. We don't want to divide by 0. We cover it up and plug the minus 2 in everywhere else. So when you do that, first you have the minus 2 in the numerator. Here, minus 2 plus 1 is minus 1. And of course, this is just going to reduce to 2. Because we're doing it on this first term, this u plus 2 term, this is going to be our a value. Okay, next doing basically the same kind of thing to get our b coefficient on the second term. We want to look at what's going to make this 0. That's going to be minus 1. Cover it up here and plug the minus 1 in everywhere else. We're going to end up with minus 1 in the numerator. Here, minus 1 plus 2, that's just going to be a 1. So this value is going to be minus 1. We'll put that in for b. So now we have these constants here. Let's take all this and plug it back into our integral. So rewriting this, we still have this 1/2 out front. I'm going to just leave it in terms of one integral. So we're going to have 2 over u plus 2. And then for the second one, let's write it for the minus 1. Let's write it plus minus 1 over u plus 1 du. We'll go ahead and integrate. We've got this 1/2 in front. Here, this is going to become 2 natural log absolute value of u plus 2. And then here, I will bring the minus up front now, so I can't make up my mind. But anyway, we'll have the minus 1 in front, natural log absolute value u plus 1. And now before we back substitute, let's just get a little simplification. First, multiplying in the 1/2, it's going to cancel with this 2 here, and that's just going to be a 1. And then I can just distribute the 1/2 in here, and we can just write it in front of this term and get rid of this. But then we'll use log properties on this. I can take the 1/2 and put it in the exponent on this, and also use the minus sign to write this as a fraction. So putting that together, we're going to have natural log absolute value u plus 2 over, this becomes 1/2 power or square root of u plus 1. And now we can just go ahead and back substitute in order to finish it off. But just notice, because u is going to be x squared, when we do that, everything here is going to be positive. This has to be positive in the denominator anyway. X squared plus 2 has to be positive. So I'll drop the absolute value and write this as parentheses. Plugging in, we have here x squared plus 2 over square root of x squared plus 1, add a plus c, and that's it. Okay, there you have it. Good one from Vienna 2024. Thanks everyone for watching. Have a good day.